our compasses and a straight edge, and we're going to use them to copy segments and angles. So we're going to do the speedy version. Again, my compass is unnecessarily enormous. Don't know why. Okay, so if I'm going to copy segment AB, the first thing I need is an auxiliary line on which to copy it. Okay, so with your straight edge, go ahead and give yourself a line that you can tell is another segment or line that's longer than AB. The easiest way to do this is to make one of the endpoints A prime. Could I put A prime here in the middle? Yeah, but then it just makes it harder on myself. So I'm just going to put A prime at one end and make my life a little bit easier. Okay, A prime tells me that is that A maps into that location. Okay, I'm going to put the metal tip of my compass on point A, and I'm going to find the distance to point B. Oh, shoot. Okay, without changing my radius, I keep that distance, metal tip on point A prime, and I mark the intersection of an arc with my auxiliary line to show where B prime should go. Okay, go ahead and try the other two. Good. Okay, so look at this. The copy is called the image. Go ahead and label him. Okay, when I look in the mirror and I see my reflection, I see an image of myself. Myself is still on this side of the looking glass. Okay, the reflection is the image. You understand what I'm saying? The original, the OG, Mrs. W is not the image. I'm the pre-image, and so is segment AB. This is the pre-image. I want you to think back to Algebra 1 when we had our cute little quadratic parent function in the coordinate plane. And we took that vertex and we used it to shift the whole function to the right and up. Do you see that the same thing happened right here? Here's my original. And then it undergoes a transformation, a shift right and up. Okay, and it maps into its new location where the image is. Okay, so what you can think of is that a transformation is like a function. And for that function, our pre-image is the input. Guess what the image is? Oh, you guys are good. Okay, if we were to make a table of input and output, A would be the input. What's the output? A prime. If B is the input, the output is B prime, and so on. Everybody okay with that? So, what if when I copied CD, I put my auxiliary line here? On this one, I attempted to get them kind of parallel. So I just, translated right and up. Okay. What about this one? What if I not only translated, but I had to spin? What do you think that transformation would be called? If I had to translate and spin? What's another name for spin?
Rotate.
Rotate. Good. Okay. Do you think I could do a reflection? Yeah. Okay, so I want you to start thinking about those things as possibilities because that's where we're going in our next unit. All right. Do we have anything to fill in at the bottom? Yeah, okay. How is the distance copier similar or different to a ruler and a protractor? Could you have kind of copied the lengths of those segments if you had like the ruler on the edge of your protractor? Okay. If your ruler had markings to just the quarter inches, would that be a better or a worse copy than if your ruler had markings to like 16ths of an inch? Worse. Okay, so 1/4 of an inch is going to be less precise than 16th of an inch, right? Okay. Does it matter any for markings with a compass? Does it matter if we're in centimeters or inches? Okay. So our rulers and protractors are only as good as our tick marks, right? The level of precision for our copy depends on how precise our instruments are. It doesn't matter for the compass. It's like dead on, no matter if we're in centimeters, if we're in inches, if we are in arbitrary made up units. Okay, it doesn't matter. Okay. All right, go ahead and flip it. Okay, we've already started doing this, but the term construction refers to a procedure that uses tools such as a compass, straight edge, to allow us to build a specific geometric object based on properties of another object. Okay, so we're going to stop here.